So for the time of today, you have the introduction to object-oriented programming, which focuses on having concepts. So all these concepts are when you have parts of the real world and you have relationships between them. So in fact, you have nouns and they exist as an instance such that whatever you have in life, you need to see it as a set and it will be of type abstract. So for example, this person can have two types. This person can be also a patient as well as an employee. Between two persons, you've also got a marriage, such that you would have two instances of persons for this kind of act. Then you've got a contract. A contract also regards a person and it can also have a car associated to it. And this car, in fact, is an instance of a model. So whatever exists, it's in fact you have a prototype, and based on an idea, you materialize it and you obtain a car. Then for this car, this is owned by a person, okay, as well as the person lives in some town. You also have the car registered to the town, like you have all the plates of the car with B from Bucharest in front. Then you have the headquarter, okay, which is in fact the main location of a company, okay, such that here you have all the executive parts of the company with all the main departments, as well as a company. It employs several persons, as well as it will characterize an efficient organization, such that you obtain a hierarchy based on it. So you can have several parts of the company and they are simply responsible for a couple of tasks. Then all of this, you can materialize it and you will have classes for each one of them, such that you have concepts that can be tangible. So, for example, a car, a table, okay, a person, or you have notions which are intangible. So, for example, time, quality, as well as company. Okay, so it is much more complex, as well as you've got roles. So roles which can be a doctor, a patient, an owner, an accountant, okay, a professor, and so on. You also have judgments. So you can have like queries based on the highest payment, which is the best example. A job. So what does it mean for a job to be productive? So you should define some parameters, some rules, as well as you've got relationships between all these instances. So for example, a relationship can be a contract, it can be a marriage, a partnership, an ownership of a company. You have an audit contract. You also got events. So based on a sale event, a purchase event, or maybe you have simple buying that you provide. Okay, so when you want to buy, let's say by negotiating, you have a market crash, as well as you've also got other type of concepts which can be strings. So whether you have a sequence of characters, a number, it can be an icon, logo, an image, whether it's a signal, a process that can be synchronous, asynchronous, such that all of these you need to taste it based on a real situation. Okay, and in this kind, you just use the concept such that you apply it in a real time situation, like based on what happens in time. Okay, you would define the highest payment, the best example, the best outcomes of a certain job, which defines a productive job according to the request and the sale that you've got for it. Okay, so in this case, you simply have these units of knowledge which you connect one with another, such that based on it you have the intention. So this means that you need to understand the concept and whether it applies or not to an entity. You also have the extension, so it means that you have the set of all these entities to which you apply the same concept. Okay, so let's say that you have this extension also for a card which can be of type credit card or debit card. So it means that you still operate with money. Then you can have the domain. So this is exactly the area of interest, whether it's the banking domain or you have the educational domain, the sales domain. Okay. Then based on it, you think which are the concepts that you need to use, as well as you need to imagine a whole real life application and based on all the notions which are included. So for example, you have the intention. So this means that you have a notion of that idea that you want to apply and to analyze, meaning that here you will have several concepts that will be used. And for it, you will also have the extension. So it means that whether you have a person, that person can be a manager or can be an employee within a company. Then you will have several events that happen, like a sale event, a marketing event. And in this case, you would have several order items which belong to some order that can be in several states. So whether you want to deliver them, whether they are cancelled, or if they were already successfully delivered. Okay. So with all these concepts, you can represent them using the object-oriented programming based on an instance. So you in fact create a copy, the skeleton of a real life situation, meaning that you also need to think of its behavior. Okay, so the behavior is translated into methods. And you need to think of the methods that are called. If they do not return anything, they are of type void. Okay. And if not, you should think of what you want to return, whether it's a string, whether it's an integer, whether it's a collection of objects, such that you will have the state of your object, whether it's available or not. So, whatever the object, you have its current state. Then, it is like for objects which you want to sell. Yes, they can be on stock or no, they can be on a limited edition, as well as you have the identity. So you should have simply you should analyze which is the behavior and the state. Okay, so whether they are distinct, okay, you have this identity for it. It is like you as a person, you are simply unique. So you have an identifier, it's like a barcode which you have for your object. And then in this way, you can analyze it, or you have a QR code and you have the identity of that product. Then for this class of objects, okay, you will define similar objects which have the same state as well as they obey to the same behavior, such that you can classify them and you will have several instances. So this class is when you define a constructor, and then you will have multiple instances of that class. Okay, it is like you are students, so you are also like objects of the class student, but each one of you is unique. So this is why you have different instances of your objects. And now for all these objects, you have attributes which are defined. Like you can define the type. Okay, you have the name, like name, first name, personal numerical number as a value. You can also have constraints. So this can be based on credit points, for example. And this can be intrinsic or extrinsic, so it depends. Like you can belong from several, so you can belong to a country which belongs to the European Union or not, so other restrictions appear. Then you've got operations. So these are in fact the methods such that there are responsibilities as well as you offer some services. So like for this course, in order to pass, okay, you should get at least 5. So you will have responsibility, and also the offered services are that you get some credit points based on which you can pass and enter the second year. But if in total you don't have enough credit points, you will not be allowed to have a new group value associated to you. So for implementing it, you simply see it as having a semantics for it. Okay, so let's say you have a point. Okay, a point is defined by two coordinates. You have x and y. This is exactly the class which was previously implemented, I think 2 weeks ago. Okay, and for it, you need to define the semantics such that you need to think what characterizes a point and which is its behavior. So it means that you will have an interface, and an interface is where you provide all the methods that can be called for it. But inside the interface, you do not code them. Okay, so you will just provide the method that can be used to read a coordinate x, read a coordinate y, to change the position x and y. So what you need to do is, in fact, to implement it by defining the two attributes x and y, and you also have your operations. So the operations in order to read a value such that you initialize it, okay, as well as you write it. Okay. So for it, you think like this. You have the class declared in Java, such that you have your public class, and based on your class name, okay, where here this one will also be the name of the file with the Java. Then you can have the extend, okay, so whether it is a subtype of something, you will also implement an interface, and then what you need to define is that you have all the fields, so all the attributes. You also have your methods. You may also have another class within it, and this is called a nested class, as well as you may define a nested interface. Then you can have several values which are added inside an enum. So you've got an enumeration based on key value pairs, and you have the constructors. The constructors are used to have objects of this class, and you can also initialize the blocks. So for example, you can have a faculty, and you start from a number of students which is equal to 0. So you have this initializer blocks. Okay, then you also have the implementation such that inside the class you define it with the name. Okay, so you have the keyword class, and then you've got the name of your class, which is employee. After that, you will define your fields. So for an employee, you will have the name, you have salary, and hire date. So you will have private in front, such that you can access it just via an object of type employee. And you define name as being a string. You will have the salary as being a double value. Then you also have the local date, which is used for the hire date, or you can have a Gregorian calendar type of data. After which you need to define your constructor. So your constructor is used when you want to have an instance of that class. So here you will have employee, for which you need to add all the fields for name, salary, and hire date, such that you define the name, this N, and you initialize the name with N. Salary will get the value S, and you've got the hire day, where hire day is characterized by a year, you've got the month, and also a day. Such that when you want to have a get means that you need to return this parameter of type string. So you return name. Then you've also got the get of salary. So you return salary, as well as you can raise your salary according to a percentage. So it means that to 1, you need to add the value of the percentage. You need to divide it by 100, and to simply multiply this value with the previous salary. such that whether you do not have any value to be returned, you can have the return of the semicolon, or you can simply have to display with system out print line, which is the new value for salary. The toString is when you simply return the name of the person. So you have the method with the get name. Then you also have the salary which you can return, as well as you got your hire date. And now when you want to have an instance of a class, you will add the name of the class, which is employee. You define the name of your object, which is John, and it will be equal to new. Okay, and then you call the constructor, which is employee. Based on the name, you've also got the salary as well as year, month, and day. Okay, so in a similar manner here, where you will have the point. Okay, yeah, this was done before. Yeah, this is course 4. So here you have your class point. Okay, but I will define it again. So let's see a new package. Course 6. Okay. And I want my class to be point. So it's a public class point. Then inside you think like this. Which are the attributes or what characterizes a point? Well, any point is characterized by 2 coordinates, such that you can have a private int x and also a private int y. So you can define them both on the same line with a comma. Then for it, you will also have a constructor. So you have a public point for which you need to provide a coordinate x and a coordinate y. And this means that the x that you've got here, okay, so this one will be equal to the value which you receive as a new parameter. Okay, so let's say this is my x and my y. See it in this way. Right, as well as you will have the y as being equal to my y. All right. As well as you see here that you will have an interface. So an interface, okay, is that class for which you define the methods. Okay, and you will have the interface, and the interface will be named point EF interface. And now what I have here is that I want to read X and to change X. So which would be the value for it? Reading X means that you want to display. Okay. Such that they are both public abstract, and it will be, you will have a void read X, okay, of int X. All right. And then for the point, you will have this implements of my point EF. Meaning that here you will want to implement the methods. Okay, so you will have an override. Okay, so what should we write here? Mm-hmm.
This dot x equals x.
You just read it and it's void. So when you read it, it means, because here this is to change it. So when changing it, it will be like you said, this dot x equals x.
Oh, to
This
read.
is, yeah. So you will have the value of x is equal to, and this will be
This
your
dot
value.
x.
So in fact, do you need this input parameter over here?
No.
Oh, so this is why here you need to have this dot x because you just read it. So it means that inside my interface, I don't need this one, and now it's perfect. And when I want to change it, okay, it can also be void. Okay, and I have change x, and here I need to provide my int x, my new x, in fact. Okay, and now I will have to implement it also here. All right, so it will override, meaning that you write again the same, this behavior of the function. So this means that it overrides the method. And now you will have this dot x being equal to my new x, okay, as well as you can display the value, okay, new value of x is equal to, and you will have this dot x, okay, as being the changed one. All right, and the same is valid for y, so you will have the void read y. And you also have this change. So whether you have this, let's say, int of change y, so whether you write it like this, you will have to return a value of type integer, and you get a new y. Let's say you have them in this way. Okay. So read x, you have the cout value of y is equal to, and you have this dot y. All right, and whether you want to change it, you will have this dot y is equal to new y, and you need to return the value for it. So you return this dot y or the new value. Okay, and when you want to check it, okay, it means that you will have a bounding static void main string args, and for
I
it,
have a question.
yeah.
Why is there the around override there on top of the classes, the function?
Because you can define it for multiple points. So you can have two classes. I can have another class point, and I can have a 3D point. Let's say I have X, Y, Z. And in my 3D point, I can also implement the same interface. Okay, implement this point interface. So it means that I can define the same behavior, but the behavior will be different. Okay, so here, if I want the read of x, I can display, and I can also add also the other coordinates like x, y, z, and just to display the value. And when I just change a coordinate, so let's say if I, so this is when for a method, you define it in this way. And let's think like this. If you've got a card and you want to take out money, you would have a different behavior for a credit card than a debit card. Because for a credit card, you have a maximum credit. For the debit card, you can take out just what you have on your account. You can take some extra money. So this one with overriding is when you can change the behavior. So you maintain the signature of the function. With the void, you have the method name parameters, but inside you can have different behavior. And overloading is when you simply add here more parameters. Okay, so this is how you overload method. Okay, so overriding means that you rewrite the behavior of your class, okay, of this method, which is change y. Okay. So when displaying, for example, I have here avoid get point info. Get point info, Okay, for my point, if I increment get point info, means that I will display what? I do a cout of, I have my coordinate x, this dot x, and I also display the value of y. So I put it in this way. But what does it mean to display it for the other, the 3D point? For my 3D point, okay, if I have the get point info and I want to display it, okay, this also has a private int x, y, z. Okay, it means that here I also need to add another coordinate, which is this dot z, and with a plus. Okay, so this is how you change your behavior. You override the same signature of the method. Okay, you've got a void, you have the method name, and whether you do have some parameters, but for the same method name, according to two types, you have another kind of behavior. Okay, so this is why it appears like this. Okay, clear now? So overriding is when you have the same return type, same method name, okay, and parameters, but within different classes, you define a different behavior. And here I can have point. Okay, this is point of P1 equals to new point. Okay, of my values. So I will have, let's say, 2 and 3. All right. So this means that over here you have your constructor. These are in fact your attributes. Okay, and then you rewrite the behavior. So void means that you don't return anything. Okay, so void equals no return. Okay, you just display the result. The result, or you modify a value. So you have some behavior behind it. And here when you have an int, okay, you have a return type. Okay. So int means that you need to return a value of type int. Okay, and this is this dot y. All right. So for this one, what we can do is to have the p1, and we can read x. We can have p1 dot read y. p1. We can change x and to become 5, as well as we have the p1 dot change of y and to be also 5, for example, as well as now I want to do again the display such that we will read them again. And you can have here a method, new coordinates after the update. Okay, or what I can do is also to call getPointInt. Okay, to have both coordinates. So you have the value of x as being 2, the value of y as being 3. Then you will have the change of x, which has a display after the value was changed, while the other one, the y, it will return an int. Okay, but when not being displayed, so you can still call it in this way without the system out print line. If you wanted to have it like before, you will have the system out print line and you will say new value of y equals, and then you concatenate it with this one by adding it within the brackets. Or if you run it in this way, you also have it in the same behavior. So this is when you call a void function, a void function which displays the result, and this is when calling a function which returns integer value. Okay, so you need to concatenate it and it will be automatically transformed inside a string. Okay, then I will add these inside the chat. Okay, and your interface. So the same you would define also for the 3D point. Okay, so it will be the read and change there exactly the same, because you have the same behavior for reading, changing, and displaying. Okay, the get point info is different, as well as you need a constructor. So these are the same. You need here a constructor, public point 3D as being int x, int y, int z, and you have this dot x as being my x, this dot y as being my input y, and this dot z as being my z. Okay, and here static coordinate. You have the string args. You will have a point of 3D, okay, as being a new point of 3D for which you define your coordinates. Let's say 1, 2, 3, and it identifies them. Then we can change the coordinates. The object point 3D, I want to change the x coordinate and to have a value 2. Okay, and in the same manner I can change the y coordinate and to have the value 3. And we can have the read of x, but this is not, so this refers to the current context of your object. But here we need to refer to the object, which is p3d, and we can also get point info, where it will display the 3 coordinates. Okay, so you have the point of coordinates 1, 2, 3. X will be changed into 2, so the new value for it is 2 when we want to display it. This one simply returns an int, but by not having it within a system out print line, it will not display anything. And when we want to get point information of 3 coordinates, it will call exactly this definition. So you override the method which is defined within the interface. Okay, so these are the behaviors of a point. Okay, while here you have a different display. So you have a 2D point, so you have just 2 coordinates. And here you have a 3D point, so it will display these 3 coordinates for your point. Okay, as well as you can concatenate it, and you can have here a system out print line, and you can say point coordinates. Okay, and you have them in this way.
Excuse me, can you go to the interface file for a bit? I want to see what is in there. That file. Do you hear me?
Yes, I hear you. So now let me finish this idea. When you have a void which you want to concatenate with another void, it will not let you, okay, because you already have the system out print line. And in this case, what you can do is to have this one as returning a string, and for it you will simply have the return of this one. Okay, and as you can see, you have it already defined, so you will have to have a 2. Okay, and for it you have the second definition, okay, such that you can display it. And now you see that you can concatenate the two strings. Okay, so you cannot concatenate the string with a void because it already has the system out print line. Okay, now let's see the interface. Yes, what did you want to ask?
I wanted to see what the interface really does.
So just define the behavior such that an interface, so you define just the methods, okay? Methods which are all public and abstract, okay? So all are public abstract. They are public and abstract because you rewrite the behavior which can change, okay?
Uh-huh.
So for example, whether you are a student in the first year, if you have enough credit points, then you pass into the second year. But if you are within the fourth year, you don't have where to pass, okay, at the end of your university year. So, or you have all your credit points and you have your final thesis filled, and then you are ready to go. So you have your diploma, and then you can go to masters. But for the other years, you just will update the year of the student year by year when you have a new academic year. And in this point, yeah.
And we update with the override, right?
Exactly, yeah. With the override, you have a different behavior.
Okay, thank you.
Okay, you're welcome. So overriding means that you maintain the same return type, same method name, and also your parameters, while inside you have a different behavior, like for get point. Okay, so get point here has two coordinates, while get point of 3D, it will display 3 coordinates. Okay, because you have a different space. Let's also add this one in the chat. Okay. Such that here you have an object. So when you have a new object, you simply initialize it. So let's see, this is the case when for point, you have it here as being with new. So you will have a 3D point for which you call the constructor, okay, which is this 3D. So this is your constructor, okay, and you initialize it. Then you have the reference, so you see that it is an object of type point 3D. And for making it a new instance of your class of point 3D, you have this new keyword. Okay, so whenever you've got a class, you have your accessibility, so it is public, and then you just define the method of the class, which is the same as the method of the file. So that's the same as the name of the file. You have point 3D as a class. You've also got the file with point3d.java. Okay. After that, you can also have a throw clause. So maybe you have throw file not found. If you read them from a file, you can also have always. This constructor, it can exist or not. So if you don't have it, okay, it will use the one by default. So what I can do, if I comment this one, okay, it means that I cannot initialize them in this way. And I simply define as having a point 3D, P3D as being equal to new point P3D in this way. Okay, and I simply set the value of x and y. Okay, so let's see what happens. So as you can see, you have x and y. You set them, okay, to the inside. Okay. as having the value of 2 and 3. So x is 2, y is 3. And the last value, z, not being set, you will have the value 0. Okay, so this is what will be displayed. And in this case, you call the default constructor without defining it, such that inside it you have your local variables, which are this one, the attributes, as well as you can have local variables inside the method. Okay, and you can have another class which is defined within it. So that one will be a nested class. Okay. Right. So I will simply have here another class. You would simply define it, whether it is, let's say it's my plane, and here you would simply have to define it. You can also call it as being inside. Okay, and here you can have a private string, okay, p as being equal to x or y, z. Yeah. Okay, so this is how you can display it, and you have your nested class. So if you want to print it, you will have for your this dot, you have the plane class p. This one is statical, so the other one should also be statical. So you've got this more actions. Okay, it's static class. Okay, but this being called in this way, you would have for that instance, let's say that this is a P3D. And you need to find it in this way. And for the class, you can also get the classes, you can cast it. Okay, so you can display it in this way. So this would be your nested class. Okay, so it is of type class, but you can also get the name, get canonical name, get class loader. Okay, so you would see what you have inside. Get fields, and you have the field by field. Okay, or you can also provide this one with public string get plane, and you have here a return of p. Okay, so for it we can have this one class, and you have the several values. Get constructors. So you can see that you have the get name, or you simply have the instance for it, such that you will have the plane inside it. Private, and then you have this plane p, okay, which you can define, okay, and to set the value for it. Okay, such that I will have a public string, and let's say whether I want to set it. This is when you create a new instance of the class. So when you want to simply get it, you will have the void, and it will be get plane. So inside it, you return for this plane, and then you have the get plane method. Okay, but this one is of type string. Okay, such that you will have to do the cout. Okay, and this is because you need to find out whether you do need to set some values or not. So you can modify this plane and to simply output the value. Okay. So here, if I want to call it, it would be a P3D dot, and you've got the plane, or you can also call it get plane in this way. Okay, but this one exists already as a void, yeah. So being a void, I already call it without the system out. Okay. So
I have a question.
Display, yeah.
Can we get the plane or set the value of plane from any class if we access it?
So you should define whether it exists inside. If you put it as being outside it, you can call it. So you cannot display a system out print line inside another system out print line. So this is why you call it in this way. So let's see. Okay, this one does not exist over here. So you've got a get plane. So you return P, but you should have the toString for it. Okay, so this one was not set. Or you can simply return a value X, O, Y, Z. Okay, because else you don't have the reference for it. So when not having a reference for it, this plane is also to be set here. So you have the P3D dot plane is equal to, you also need to set it as a new plane. Okay, and now you've got a constructor, because else you have it as a null pointer. Okay, and now you see that it is of type plane, and for it, it will display the result. Okay, so you return the value or you return this P. If I run it again, okay, you've got the value. All right, so now to return to your question, okay, you can also have the driver class. So I can have a driver for my point, where this driver point is in fact just a public static void main, and you've got the string args. Okay. For it, what I can do is to have this point 3D. So what you've seen here inside, I can place inside my driver. And this is how I can access it. All right. But this one, this is the inner field of it. So this is why it is simply hidden by what you have here. Okay. So this is placed inside, this is the nested class. All right. And for it, it will not see, you have a private access. Okay. So when being inside it, you can access it as being the nested class, or not, you can have the simple plane. But if you put a plane to be public, okay, you will have it here. Okay, this one, the reference for it also needs to be public, or else you cannot access it from outside the class. So before, when it was private and it's a nested class, for it it's all right, you receive exactly the outcome. But when calling it from here, you need to define it public such that you can see it. Okay. So here you've got plane as a nested class, okay, of point 3D. And this is why when having it defined as an attribute, okay, you need to have it also with public. Okay. Okay. So if you define the plane S with private, okay, you cannot just you cannot create it. Okay, but if you set it, if you define the plane inside the class this point 3D as public, so you've got okay. Alright, then it will work because you can access it. Because you can. Okay. So if I go here and I make this one public, then it's all right. I can also run it from here. Okay. So as you can see, it's the same because this plane is the inner class which exists inside the class which is point 3D. This is why it's displayed like this. You've got the package PL, then you have C6, and then it looks inside the file which is point 3D. And for this point 3D, it looks at plane, okay, which is this one. So this is called the nested class, okay. And this is how you define it. Clear for everyone?
Yes.
Okay. Let me throw one over here. Anyway, you will have the whole classes at the end as an archive. Okay. Returning to this one. All right. You've got the constructors. So these constructors are what you define over here. So you can use the default constructor. So it means that the values will just be equal to 0 or to an empty string. This object will be null. As you've seen, it wanted to be initialized. So if I don't initialize this one, it will say that it is null object. Okay, as you can see, you didn't allocate it, so it will be a null instance. All right, as well as you can have an abstract class for which you call super. So for this one, this is the way when you can have a card. So this card can be of two types. It can be a debit card or a credit card. So it is a public abstract class card. And for this card, I will have a private string. I have a bank. I have a private int amount. All right. So in this case, you will have to define it, but so here you will have to call the constructor. You have a public card of string bank int amount, and I will say that this dot bank equals B, this dot amount equals A. Okay, then I will have the public. You have the getters. This means that I need to have a string of get of bank because I return the bank, so I don't need any input parameter. So no input parameter because I do not modify a value, I just return it. Okay. So it means that I return my object which is bank. So let's say that it's the current instance of the object, and I have a public for int to get amount. I return an integer of get amount, and I return this dot amount. If I want to do the setter, it means that I have to modify a value such that I need an input or more parameters. So it depends on the logic. such that you cannot.
Do getter classes work better if they are in an abstract class?
They are the same. Whether you define it in an abstract or another public class, you just have access to your attributes. So this is how you can access them because they are of type private. And this is why you've got the getters and setters, which are public. Okay, so they are attributes of a class, and no matter if you have them inside a public class, like here you have the point with change and get x, okay, this one, get point info, or if you put it here with getter setter, when being inside the class, so whatever card you've got, whether it's a debit card or a credit card, it still has a bank and an amount. So this is why you define it here. This is the skeleton of what you know for this concept, which is card. Okay.
Okay.
So when defining it here as being an attribute of your card, you also have your getter setters. Okay. And for your setter, it means that I don't need to return anything. Okay. And I will have my set of bank, which is with string new bank, right, such that I have my this.bank equal to new bank. Okay, so void means, okay, void return type equals no return of certain value. So you just update a value. Okay, you just update value. Okay, based on a certain rationality. So how you want to update it, based on a percentage or not, or just based on a value. Then I want to also set the amount based on my new amount. So again, I set it to a new amount, which is of the same type. Okay, so you update a string using another string. Okay. You update a string using another string as an input parameter. And here you update an integer by using another integer value. Yes, so it makes sense that you set a value to be equal to another parameter which is of the same type. You won't set a string to be equal to a number. A double makes absolutely no sense. Okay. It is like you have a person or a point, and I put the same structure like setting some barcode. Makes no sense. So you will have this dot amount as being your new amount. All right. Okay, and don't forget that you also have the part with the toString, such that you will have a public string toString. Okay, where you will return the notions about this bank. So you have this dot get bank or this dot b plus, and so when you want to display the value of a card, you want to have access to all of these, or else you can get an offset of the memory. And I'm not interested in that. Okay, so this is the basic skeleton of a card. Now, if I want to have a debit card, what I would do is to have this extents of what? Of my class, which is card. And what it will want here is to create the constructor. So now when having the constructor, you have the super with your bank as well as the amount. And here you will have a public void. I will have to extract some money. Okay, so you will just take away a sum of money. So you have the withdraw withdraw some money. So withdraw according to an amount. So I have a sum. And here, what should you do when you want to withdraw from a debit card? You should have what? If this dot get amount is how? Based on the sum that you want to withdraw.
So basically in the withdraw function, we want to say if the amount is less than what we want to withdraw, it has an error, and if
Okay.
and otherwise it does the it withdraws the amount. It sets the amount to the new amount,
Which is?
which is the this that get amount, yes, minus the amount we want to withdraw, right?
Okay, perfect. And you will simply display like the transaction was done successfully. Okay, so it was successful. Okay, success. Okay. Yeah, it is good like this. Yay, thank you. And now, when I want to create this instance, let's create it in another place, not to mix them up. If I would like a credit card, and I do this extends of card. All right. A credit card also has a maximum credit. Okay, so I would set here int max credit, and this dot max credit would receive my max credit. Okay.
Why do we have to put this dot max credit equals max credit? I
Because it
tried it in
shows,
some problems
yeah,
and it didn't work if we didn't put this.
because when creating an object of the class, this is when referring to itself. So it is a pointer. You've got the whole object, and then you have the address spaces for each and every attribute. So basically, for an object of type card, you set this attribute associated to it, which is your maximum credit. So this is in fact a pointer. For your current object of type credit card, you will have to set the maximum credit. Okay. So it's basically just based on pointers and address spaces. So this is how you simply access it. And for it, I will have to withdraw. So it's a public void withdraw of an int sum. And here, in fact, what will you have? So let's take what we have here, but it will be a little bit changed. So here, what should you do? If your current amount plus the sum exceeds the maximum credit, then you cannot take it out. Okay. Or else, if they are equal, then you owe the bank much more money. Okay, when you want to withdraw and to buy something new. Clear? So you can take money up to a maximum credit, okay, such that if you want to borrow money, you take the sum of the money which you want to use, and you should not exceed your credit. Okay. So whether it exceeds, then it's an error. If not, you simply update the amount, and you also have a successful operation. While what do you see here? You've got the withdraw, which exists also in both of them. So in fact, when having two behaviors for it, you can have here an interface, and you will have a card interface. Okay, and you will have this void withdraw of an amount of money, a sum. Okay. And what you will have here, you will have to extend card, and here inside you will have what? It will implement this card interface. But this is when you just define it. Okay. So it means that here inside you will have this implements of card interface. So it will be this withdraw. Okay. So as you can see, you have to implement withdraw, and it will simply override the behavior. So it will be exactly, you do the override of your method. Okay. So here, when you want to implement it in fact, you just have it defined as abstract void withdraw, and you put it in this way. Okay. And this means that even inside it, okay, you need to implement the methods. So it will want the withdraw to be in front. Okay, you have the card interface for it. Okay. I have withdraw and withdraw of sum. Let me clarify. I have withdraw of int sum. Okay. And this one already will exist from here. Okay. So, right. So we have the override according to the sum tag. And this is just the recap with withdrawing. And you have the override for the method. Okay. So in this case, you will simply override the method. So as you can see, this one, the card implements the interface, and it will have one related problem, which is this one, because you don't have the behavior of withdraw. Okay. And here you can also name it specifically as implementing the interface, but we can skip this one. And it will still say, so if I don't have it, it will say that you need to implement it. Okay, so you have this implement abstract methods. Because inside card, you just have these implements, but when creating an instance, you need to have it here inside. So this is how you can do it. And now let's try this class. So you will have the card driver, meaning that
How do you put everything in the comments like that?
You just select it, and then you have the control and you have the slash.
Thank you.
You're welcome. So, comment by selecting the lines. Okay, then you have control and you've got this tag, and then it works. Tag, and that's it. Okay, good. All right. Or what you can do is to also add things like this with the star and slash. Okay. By using slash hook and on multiple lines. Okay, for the sake of the example, I will add this one like here, and then I put it again. Okay. So Yeah, okay, let's also add this one in the chat. Okay, так. Then I want to test this example, so I have a public static void main string args. And I will have the two cards. I will have a debit card as being a debit card 1 equals to new debit card. And for this one, I need to set which is my bank and the other amount. Okay, some amount. Okay, and I also have the other one, the credit card CC1 as being new credit card of my bank. And, oh yeah, some. And thus I also need a maximum credit. Say that it's like this. Okay, what I want to do is from my debit card 1, I want to withdraw an amount of money, which is 20, such that, let's say, cout dc1 dot. I have get amount, and I will have here debit card amount equals to plus. Okay. All right. Then I can even have more than this and to say that I have 200. So we have 120. After subtracting, I have 100, and whether I want to take out more, I obtain an error. Then for the credit cards, okay, I have CC1 dot withdraw. I have this 100. I can reach 2000, so I can withdraw 1500. Then I can have my credit card amount being credit card 1. This is with plus. Okay, get amount. Right. So yeah, I can run it from there or from here. Okay, it is okay because it did reach the limit, but it wasn't exceeded. And now when I want to withdraw again, even something less like 10, okay, it will not let me because I did exceed my account. Okay, so this is how you can call each and every instance of the class and call the withdraw method, which has a different behavior for a debit card and a credit card. So this is why you have an interface. An interface defines the method, and you have to implement it to define a different behavior for them. Okay. Clear for everyone? If you have any questions up to now. So as you can see with this constructor, with the credit card, it extends card, which is abstract because you can have two types, as well as this one will implement this interface, okay, such that inside debit card and credit card, you need to override the behavior of this class. Okay, so you call it with super, and the other one, if you have another attribute, you just set it according to the value which you wanted to have.
Excuse me, could you explain one more time what super does?
Super is when inside the class which is credit card, you want to call the constructor which you did define here in the abstract class. Because whatever class you've got, whether it's a card, whether it's a debit card, okay, you still have a bank and an amount which is associated to it. Okay, so this is like when you have something, a public class person. Okay, you still have a first name, a last name, and an ID, whether or not you are a student or whether you are a professor or whether you're a secretary. So it is the same thing which characterizes you as a person. And here, as the concept card, you have for debit and credit also bank and amount. Clear?
So basically it builds the bank and the amount, right?
Exactly, yeah.
Okay.
You have the bank and amount which characterize an object of this type card. And then you simply split it into two types. Okay. This is like you have a class person. Yes, and then you have the person who has two genders, okay, male, female, okay. And in this way, you simply separate them. But them as a person, you are still one individual. Then what you can do here is to overload your constructor. So you can have more or less attributes. Like here, I can have the two of them. Okay, like I have a bank and I have amount and credit. But for the same class, what I can do is to have just public, I have credit card, and I just want to set, let's say, the bank and amount, but I don't want to set the other value. Okay, so this means that I will have the super of the two of them. I have bank amount. Okay. This was amount which is string, sorry, int A, and now it's okay. So this is overloading it. You can have more or less parameters according to the type. Okay, it just says that it's not used. This is why it's different color. Okay, and then you can set your credit. Okay, so you can have them one by one. So when you have something like this, you should also have a public void set max credit, okay, with a value which it ends max c, such that this dot max credit is equal to max c. So when defining something like this, I will have a credit card 2 as being new credit card of and some amount. Then for it, I have cc2 dot set maximum credit, and then I can have this one, and I can do the same. So c2, c2, c2. All right, so let's see what happens now. I have another credit card, okay, with 200. I set this limit of 2000. I take away 1,500, so it's okay. I did reach an amount of 1,700, and thus I can take away again a 10, and I will have another new amount with 1,510. So this is when you can use different constructors for your credit card, which you can define in this way or in the other way. So you can overload them. Okay, this is the way when you overload. Okay, so you have these overloaded constructors such that you maintain the same name. Okay, and you have multiple attributes or less. So you just change the number of parameters, input parameters. Also, you have these relationships between the classes, such that here you see that for an account you have multiple orders. Okay, so you have this multiplicity. Then you have this order which contains multiple items. So as you can see, one item of type chocolate will belong to multiple orders, okay? Such that an item can be repeated when you want to buy it. Okay, so you can have this dependency with uses a, so the order manager will have an instance of order inside it. You can also have your association. when you have this kind of knows somebody, so you have your defined relationship, you also have your aggregation, which is this one, when an order is composed of multiple items that you've got based on a barcode, as well as you have your generalization, as this order can be of type rush order, okay, as well as the card, you can have it of two types. So if I would like to, let's have my snippet, offer something like this, you can also have your class, which is card, and this card is of two types. So when having card of two types, it means that I have this kind of operation, and for it I can have a type which is your debit card. Okay, so you can have your debit as well as you can have your credit card. So it means that they are very similar. Okay, and here you've got your credit card. So this one is with credit. Okay.
I have another question. What
Yes.
do overloaded constructors bring in a plus from the normal constructors?
You can set multiple attributes. As you can see here, you can set 3 values, while here you set just 2 values. And this is why you need to have your setters, extra setters, like here. Okay.
So we call an overloaded constructor a constructor that has, for this example, super B and A and this dot max credit, something like that, right?
Yes, so this is to call the constructor of card. Okay, this is why you've got the super. And here you set also these 2 values and also max credit. Okay. As well as you can also, so let me paste this one here to rename. So what I can do also in another way is to have just a public credit card, and I just set my int max credit. So I have this dot max credit as being my max C. And what I need to do here, this is your public credit card, credit. It says that you want to have the one with super. But what I can do, yeah, it's just this. It will be also to edit without no constructors inside card. So you can have it with this one. And then you have the set amount and set bank. Okay. So you also need to provide it in this way. Then you just set it in okay here. And let's have the other definition. So you have a credit card CC3, which is new credit card of my amount. Okay, so this is the one. Then for my CC3, I need to set bank. Okay, CC3 dot set amount, whatever, and let's copy paste. It will be this one. Okay. C3, C3, C3. Now let's see. So this is another case 3. Okay, so in my case 3, okay, this means that you set some amount and a maximum credit, so it won't let you take it away. Okay, I set a lower amount than the maximum credit. Okay, so you set your amount you want to withdraw. Okay, so you've got just this credit amount, as well as you want to take a sum which is lower than it. Okay, so what you can define is for a credit to have all 3 attributes defined, bank amount max credit, or you can do it in this way, okay, with max credit, and then you set your bank and amount. And this is when you have this overloaded constructor. Okay, you define it in a different way. You have 3 ways of defining it now. Okay, all 3. 2 arguments, okay, here 3 arguments and 1 argument. And here you don't need anymore the super because you don't define the bank and the amount. You just define them afterwards. Okay, clear?
I think it's clear.
For overloaded, you have various input parameters. Okay, you have 3, then you have 2, you have 2 input parameters, same constructor, and here you have 1 input parameter. Okay, but you have the same name of your constructor. Also, inside your UML, you will have your class name, and based on your class name, you will have several attributes with a type or an initial value. So whether you have an equal, you have initial value, like maybe you want your currency and to be euro or lei. Then you've got your operation. So you've got the operation name, you've got your parameter list, and then you've got the return type, as well as you can have some abstract operation. So the abstract operation which you've seen is in fact the withdraw. Okay, so you have this withdraw, which is abstract. Such that here you have your super type and type 1 and type 2 being exactly what I did draw. Here you have the card, which is debit card or credit card. Also, you can add a constraint, which is put between the curly braces, such that you have the name and description. You also have a stereotype. You also have comments which are associated, as well as you have an object or an instance of the class. So you have the object according to the name and its type at the end. Then based on 2 classes, they have roles. So you can have just one class is associated to another. So you've got just this one. You can have multiple instances of it. So you've got the star. Maybe you don't have any instance associated to it, so you have a 0 or 1. So think about a company and you have another manager, so you can have someone above you or not, so you can be the CEO of the company. Then you can have a specific range from M to N. You can also have them ordered, as well as you've got this aggregation and composition. So aggregation is when you've got them multiple and they can exist without one another. So let's think that you've got your money, which your wallet, which has an amount of money, so some banknotes. But if you think about a human being and a heart, they are connected, and this is why you've got this composition. Then you will have your qualified association. So based on a certain qualifier, you just link it to another class. You can also navigate. So you've got this source and destination, meaning that inside the source, I will have a reference to my destination. So it is like here, I have for a client, I need a provider. So this is like when buying, for example, from a mug, you have a client, he placed an order such that the client's order depends on a certain provider according to the key, the identifier of this provider. Such that you've seen that you can group all these classes inside the package, which is exactly what you've seen each and every time. Here for every course, I did add everything inside the package such that you have them all grouped, so you know how you can organize them and you have them one by one. Then also for all the other packages, you have them inside the Java lang or Java util. So whenever you have a library, even inside Java, when it's written and it belongs to a predefined Java library, it will start with Java, and then it depends whether it regards a language or some utility or some network package. Also, you have several packages which you've got inside. So like this flow.com. So even here, the car driver, it exists inside what? I have my src, it will be inside Java, but being inside Java such that I can compile them, I have another package above, which is this PL. Then I have my course, which is 6, and inside it, I have my interface, which is here. So as you can see, you have these interfaces defined with this logo of I. You have classes with C, and whether you have a void main inside it, you see that you have this player, the green player icon. And whether it's abstract, you have them with these lines, okay? Because you cannot instantiate an abstract class with another abstract class, you need to have it of type debit card or credit card such that you have exactly the classes which extend its behavior. Okay. Such that when you use here date exists inside the package which is Java util, and you initialize it with a new Java util.date. So you call this constructor. And this is when you have them placed inside the different package. So it's again with this credit card and so on. All right. Then you can have your modifiers such that you've seen that you have your public, protected, default, private. So you've seen the difference when you had it with the plane, the points and the planes, okay? So being this one, when we had the nested class. Such that for accessing it, it can be inside the same class. So you can access absolutely everything. As inside my 3D plane, I could access the plane, which is here. But in order to access it from outside, okay, inside the driver point, I had to make it to be public. This point inside my point 3D. So here, to make it public such that I can access the nested class. Then, whether you are inside a different class but inside the same package, okay, you have access to your public protected default, but not to your private ones. So this is why before you were having it here with private, and this is why it wasn't letting you access it. If you have again a subclass of the same package, again, whether it's private, you cannot access it. Now, whether you have a different class and a different package, so like I have here from this from the package C4 to access the others, all that is public, okay, can be accessed, but the others, you cannot access them. And whether you have a subclass, but you have a different package, you can access the public and the protected because it's a subclass, okay? So you can access its fields. Then you can have some final fields. This means that you cannot have them as subclasses, and also you cannot change them, neither at runtime, neither at overriding them. So it would be like you have a currency and you set it to just the final value. Then you can have a method which is synchronized. So this means that you will have a lock for your code, and whether a method is synchronized, it means that you will have a thread. It will access, okay, the code, and it will simply put a lock until it finishes to execute the whole body of your method, and then when it finishes, that method can be again called by another thread. So a thread is in fact another process which wants to simply call some resources.
But the synchronized method will the methods there will not go simultaneously, right? They will go.
No. You have a single flow. While in asynchronized, you can have them again called. You have another thread which calls the method, and they simply run in parallel. Okay. So with this synchronized, it's like this. Okay, you have here your process. So I have my process, which will simply call the method. I have a lifetime of this method, and then it will simply have the result, such that if I want to call it again, it simply needs to finish, and then I can have again the same method called. Okay, and here you've got some time span when you have this code executed. While when having it in asynchronized, okay, you can have one thread, it's accessing it here, and then you don't need to find to get the response. Okay, you will get some response, okay, in the meantime, but you can also have another process which can call the same method. Okay, so you can think about tables, let's say, and based on a database to find out the records such that you get them in parallel. Okay, so this is your synchronized. Okay, this is your sync. And asynchronized is when you don't need to get the response, okay, such that another process can call it again. Okay, so you can have processing running in parallel, but here no. You need to have a lock. So as it says, you have a lock on the section of code. And this is your section of code with a method, okay, that you call. And this one needs to end such that you can continue. And as you can see, only one thread. So you have this one as being your thread. Okay, or in Romanian, it's field execution. Okay, so you have just one process which will call it, this certain method. Okay, so let's display it here. Also, you can have the transient. So it means that your variables are not stored as serialized objects. So serialized is when you have them all compressed such that you want to store them and to display them to some network. Okay. So it means when you have them as a sequence of 0 or 1, so that you can parse through them. Then you can also have the native. So it means that you have that method implemented just in the code written in C or C++. And volatile is when you want to synchronize, and you want to synchronize all the copies that you've got in the system. So in the main memory for it. Okay, because maybe you can change it and you have the same variable stored, like you have the same variable I used. Then you have your visibility modifier. So you've seen that you've got the public, you can access it from anywhere. The class is accessible, and even the methods, you can also access them from outside. Then you have the private. So this is when you can access it just from the methods which belongs to the exactly same class. And in this case, you simply hide your data, so your attributes which belong to the class, okay, when wanting to access them from outside. Protected is when adding it to variables or to methods, you want to be used just by the methods which are placed within the class, or for those when being in the same package, you want just for those classes to be called, as well as for the same subclasses. Okay, and in this way, with the protected, they are just inherited. Okay, based on the same or different package. Okay.
So with protected, they don't change in the main program, right?
No, it is like here. You've got the card. And when I wanted to use the credit card without calling super, I needed to have a default constructor for card. And because it had to be used within the same package, it is protected. Okay. And then for it, what I can do is to set the bank and the amount. So this is what I did inside card drive. Okay, this one. I have an instance where I set just the attribute of my credit card, and then I set my bank and my amount. Okay. So you also call them within the same package as you've seen. Okay. As well as you can see, you have these protected variables which are also inherited by your subclasses. So as you can see, this one, the credit card extends card. Okay, here I have just one parameter, which is my maximum credit. But what I was able to use is set bank and set amount, which were defined inside the abstract class. So this is how it was protected, and via this abstraction, you were able to use these public methods. Okay. And default means that your visibility, so it was simply omitted, and you will have them available just within the class or for the classes that you have them placed in the same packages. Okay, as well as they are also inherited by those subclasses that you have in the same package. So we refer again to this hierarchy, and whether you have them inside, be careful like with the point. When it was private and accessing from outside, it wasn't able to do it. Okay, because here I did change it to be public at the end. This is how it worked. Okay, so just be careful when accessing it from outside. Okay, then you can also encapsulate such that you've got private fields and you have them accessed via interfaces with getter, setter. So this is what you've seen. Get of some field name and you return exactly the type. So you have them here with the card. Okay, you get according to the type, you set, so you have void because you don't need to return anything, you just set according to the type and the field which you define inside. Also you have this, so this is in fact a pointer, and you refer to the current object. So this is when, based on the current object, you can call your instance methods, and you can also access it outside the non-static context. So it means that you access it outside any void main, so as you can see over here. Then you can also have some local variables which will simply have a shadow of an instance field. So here you've got the instance field which is name, you have the constructor for the person, and whether you want to get the account, you simply use for the accounts, you can have multiple fields and you go according to the length of it. So you can define here inside other local variables such that you can parse through the records, or you can compute a new increase, let's say for the salary of a person. So when you have a method inside, when you have a variable inside a method like this one, it will be called a local variable. And here is when one person lives at a certain address. So this person will have an instance of address, and then this account will have several instances. So person will have here an array of accounts. I know that I also did it. It was last time. Okay, you have account, bank. Mm-hmm. Yeah. And we were simply adding money for that account. Serialization. Yeah, based on the money. All right, so we'll continue next time with the whole OOP concepts as a review. And don't forget that you've got the test. So the test will be exactly from what was taught until now. When you were defining arrays, you were having different types, also your collections, using matrices, as well as one example will be a simple one regarding these kind of classes. Okay, one of the exercises. So I will stop the recording. Okay.